Good morning, folks. So this morning's speaker is a seasoned speaker at C++ Now. Actually, I expect that most, if not all of you, will already know him one way or another. So he's been here for about 8 years, and he's really well known for his engaging and thoughtful talks ranging from math and functional programming all the way to software engineering. So I can definitely tell that personally, I've been influenced by his talks in the past few years, and I'm really thankful to him for that. He's also a member of the C++ Standards Committee, where he's involved in very impactful proposals like language level variance, pattern matching, and recently the reflection TS, where he's also the editor. But the most impactful thing he's done in the committee is get me to join. So he has a wide experience going from computer vision all the way to dependently typed programming languages, but he currently works as a team lead at Bloomberg, where his team is the core microservice team. And so without further ado, please welcome engineer extraordinaire and personal friend of mine, David Sankel.
Cool. Hi, everybody. It's too early. It's too early. All right. So we're going to talk about the coolest TS to be published in the past year, right? It's also the only TS to be published in the past year, but it's definitely the coolest. So first off, I have been working on this TS with some excellent co-authors. So Matoush from Global Logic and Axel from CERN, like this definitely would not be happening at all without them working on this, and it really was, in every sense of the word, a joint effort. So, so that being said, there are a bunch of references here. You can look at it afterwards. The only one I want to point out is that static reflection in a nutshell. That one is probably the most accessible introduction to reflection. So if you want to take a look, that's probably a good place to start. But there's all these other papers that you can use to get there. And also, I should have mentioned on the contributors thing. So these are co-authors, but really so many people in the standardization committee like have contributed to this project. And we tweaked the proposal based on their comments, like competing proposals, all this other kind of stuff went into it. So it's really, I mean, we can't claim credit for this thing. So many people are involved. What is reflection? What do you think? Can somebody tell me what reflection is? Okay, just shout it out. Introspection on members and functions. A hook into the AST. All right, so it's lots of things. It's right along these lines. So let's take a look at this code. Many of you have probably written code that looks like this. We have this struct called getInnerType, and it takes a single template parameter, and it has a single type def on the inside, which is just called type and is equal to that t thing. All right? We have a partial template specialization for vectors. So if you have a vector, instead of putting vector as the embedded type there, it'll just use t. Pretty basic. If you use it down here, if you pass an int, the : type thing results in an int. If you pass in a vector event, it'll again have an int because it goes inside the vector and pulls the int outside of it. And then finally, if you have a vector of int, what this will do is it'll return the vector of int. So maybe that's not exactly what we wanted. Maybe we wanted to get the most inner type. So if we revise this and say using type equals type name getInnerType type. A lot of types there. But at any rate, it basically is creating a recursive compile time function to get the innermost type. So now this does what we want it to do. Vector of int type. So we're kind of, in a sense, reflecting on types. If you look at the C++ type traits library, you have all these different things in here. Is void, is integral, is class. All these are things that you can use to inspect your compile time types and other things. So we kind of have a lot of reflection already in the standard library. And this is definitely not exhaustive here. Is invocable is an interesting one. This is quite a complex thing. So is invocable, I don't know if you've ever messed with this. but the first template parameter can be something function-like. It could be a member function, it could be a free function, it could be a lambda function, it could be a function object. You pass in these argument types as parameters, and it'll tell you if you can actually invoke that somehow with parameters of this type. And then there's an invoke to actually do that kind of thing. But anyway, this is a very complex introspection type functionality. If you look at boost function types, and we're going to talk a lot about boost in this talk. There's a ton of boost libraries that make use of this stuff. There's this thing called parameter types. And what you do is in that first template parameter, you pass in your function-like objects or your function. And what it does is it has an embedded : type like we saw in a couple slides ago, which is a compile time list of types of its parameters. This is, in particular, produces an MPL sequence. And once you have an MPL sequence, you can do all kinds of neat things with it. You can make a tuple out of those types. You can take that tuple, then you can invoke that function with it. There's a lot of interesting things that you can do in terms of reflection with C++ right now. So the key observation here is that C++ already has compile time reflection. Okay, I think we're done. Okay, I was waiting for that second nervous laughter. The third one would be stretching it a little bit. Okay. So what else do we need if we already have reflection in C++? So there are a lot of applications that we have with reflection. We've got boost bind, which became standard bind. That has to do a lot of reflection in order to figure out the result type of the functions that you pass into it. Boost HOF, higher order functions, like if you want to do fold or something like that in C++, that's a really neat library that needs to reflect on things in order to make things work. Boost parameter, I don't know if you ever messed around with this one. This allows you to write functions that have keyword arguments in C++. So it's pretty fun, but there's a lot of heavy machinery under there that requires reflection. Boost Python itself, like that sucker, to be able to take an arbitrary C++ function or C++ object and with minimal syntax expose it to Python, you need to reflect a lot on C++ in order to do that. And then Boost TTI. So maybe we have enough, or maybe something's missing. Well, let's just say something's missing. So Boost serialization library. So this is a library that you can use to annotate your types with some kind of boilerplate, and then you can serialize this type to disk and unserialize it from disk. Really nice library. And the way you do that is you have this serialize function, and the details aren't really that important, but the key thing in here is that you take this AR, this archive, and you mention your local, or your data members there. Now, if you want to use XML, you have to do some more work. Because if you're serializing the XML, not only do you have to know the value of these data members, but you also need to know their name if you want to have decent tag names in your XML. So they invented this make MVP thing where you pass in the name of the type and then the actual value of the type, and now you have enough information to be able to serialize to XML. But look at all that repetition there. Latitude, latitude. What can we do to improve this repetition? Macro. So you can use Boost serialization MVP instead of make MVP and just pass in latitude or longitude, and then it works okay. All right. Still seems like we can do better. So Boost Fusion. This library is super cool. So fusion is in the sense of you're fusing types and values together, and you can do interesting things at compile time with these types and values. So one example here is you have a standard tuple with int and string, and you create it with a couple of values here. And then with Boost Fusion, you can call begin on that tuple, and what you get is a compile time iterator into the tuple. And so we dereference that sucker, and then when it outputs 101 is the first element. And then similarly over here, the compile time iterator, you call begin on this thing, and you call next on that, and then you get the second element of that tuple. You can do interesting things at compile time with this kind of functionality. But what if you want to do the same thing with your struct? Well, if you want to do the same thing with your struct, you're going to have to use this boost fusion adapt struct macro. We love macros, right? And what you're doing is you're basically telling Fusion, hey, these are the data members, name and age. And once you do that, now you can create a value of that struct and use the iterators like before, and it just works. But you're going to have to opt in to this kind of thing. Would C++ 17 change that with structured bindings? Maybe a little bit. It might get us a little bit closer. I forget if, I don't think, yeah, there's some really crazy things you can do with structured bindings that were not intended, and you can extract elements, but. Okay, another comment, we're not quite there with structured bindings. Well, let's move on for a sec here. So there is a ton of boilerplate there, right? Well, not a ton, but you're having to repeat all the data members. And if you're working with this kind of library and you opt into Boost Fusion for all your structs, there's a danger that you might add a data member to your struct and then forget to add it down here. So the Boost Fusion folks thought the way that we can solve this is with more macros. So you declare your struct using a macro now. And this first argument to it is empty. This is something to do with namespaces, but we don't really care about it. But anyway, you pass in the name of your struct that you want to create. You pass in your data members, and it creates your struct, and it creates the opt-in for Boost Fusion. Yeah, you can do it. Doesn't feel very good, though, does it? Okay. So the reflection TS focus, what are we trying to do? How did we make this design, and how did we come to the design that we have right now? The first one is that we want to provide only what's missing. We're not trying to make a whole new way of doing all kinds of reflection in C++. The reflection that we have is already fine. Let's just extend that with what's missing. Okay, so it's not a revolutionary new way of doing things. The second element is that we're focusing on use cases. There's a lot of reflection that you could do in C++, but not all of it actually has a use case or a good use case. And depending on what you reflect, it's going to have more or less pressure on compiler vendors to do some crazy stuff in order to make it work. So that's the third element here, is that we're focusing on implementability. Compiler vendor feedback has been incredibly important in the design of this TS, so that we made sure that when we publish this thing, it's going to be readily implementable by any compiler vendor you want. And the other focus is that we're making a low-level API, the bare bones stuff. It doesn't have to be very pretty, just like very, very small, precise, like bottom things. So if you look at kind of like the way we're looking at it, what we're providing here is reflection facilities. Just very, very small, low-level things that people can use. And the expectation is that someone's going to come along, maybe one of you, and make a reflection library out of that. Something that's a bit higher level. When you have a reflection library, then someone can come and make a domain-specific library, like a serialization example or something like that. And ultimately, you have the end-user code, which is using something along these lines. Now, the amount of C++ hackery that you need to know increases as you go down this tree here. And the number of people that need to be aware of that hackery also goes down as you go down this tree. So reflection library, a few experts are going to be producing this. Domain-specific libraries, you have to be an expert, but less of an expert in order to be able to do something like that. And for user code, you don't have to be an expert at all. So the basic syntax here is we have this reflexper operator. I don't know about that name. That's the name that we got. bike shed. That was like probably the longest bike shed session I've ever seen. And we ended up with what we started with. Okay, but we have reflexbr, and you put some kind of syntax in there. And what this produces is an unnamed type. And this unnamed type satisfies certain concepts. How many of you are familiar with concepts? Okay, almost everybody. That's great. So once you have this unnamed type that satisfies concepts, there are certain operations that you can do with it, and it's pretty straightforward from there. Now, not every syntax can you put in there. You can put in types. You can put in certain expressions, some other things, limited based on those use cases that we talked about. So everything that you reflect with reflexbr satisfies this object concept. So these object concepts have a bunch of operations associated with them. So anything that you reflect, you can use these operations. You can see whether or not two things that got reflected, so we call that a meta object. You can see whether or not they are reflecting the same thing with that function there. You can get the source line, the source column, some of these basic things that everything you reflect should be able to give you this information. So we have also these _v and _t shorthands. Like we frequently see in the standard library, they have this base thing with a nested colon type or colon value associated with it. And then you have the _t and _v aliases, which make it all so you don't have to do that extra syntax. So for what we're going to do in this talk, we're just going to talk mostly using the _v and _t shorthands. So here's an example. We got a struct, has a single data member, and line 0, line 1, line 2. So reflexbr on S. And remember that reflexbr returns some type, an unnamed type. We don't know its name, but we know that it satisfies certain concepts. It satisfies the object concept for sure. So we can call get source line v on it. So that's going to evaluate to 0 because the S struct is declared on line 0 there. In the reflection TS, we also have this idea of sequences. So this is like an MPL sequence or something along these lines, a list of types. And anything which is an object sequence has these operations associated with it. You can get the size of the sequence, you can get the element out of the sequence, and interestingly, we have this special unpack sequence v. So this is the one thing that we added that is pretty much purely a convenience function. And what you can do with unpack sequence is take your object sequence, which you got through reflection, maybe you're asking what the data members are, and move this into insert your favorite compile time list of type library that you want here. So an example here is if we have some sequence, which we got through reflection somehow, and we want to put it into a boost fusion vector, we could just call unpack sequence v and put it into a boost fusion vector. And then use all of these metaprogramming libraries that already exist to do things with it. So, some stuff is in and some stuff is out. What is in? We can reflect on data members. We can see what the member types are. So if you have a type def inside of your class, you can reflect on those and iterate through them. If you have an enumeration, you can reflect on your enumerators. There is template instantiations. So what I mean by that is if you can reflect on std vector of int. That's totally cool. But what we don't have in is reflecting on std vector, the template itself, right? That's out. You can reflect on aliases, so any type defs, you can see through them, you can get their name, see the name of the thing that they're pointing to. You can reflect on function declarations and lambdas, we'll talk more about those later. Now what's out, that's notable, is first reflection facilities that are already in C++. We have no way for you to query whether or not a particular type is const. We already know how to do that with the existing facilities. We are not reflecting on namespace members. This often comes up like, oh, could you reflect on all the elements in a namespace? Well, first, why? But second, I think the compiler vendors would lynch us if we had added something like that in there, because it would just blow up almost every single time that you used it. So we don't do that. I mentioned we don't reflect on templates. We don't have a way to build new data types, like by generating a new clean identifier for something. This is an extension that in the original design proposal is well thought out. So we'll see how reflection goes in the future, and ultimately I think that we're gonna need something like this and we'll be able to add it. And we're not reflecting on attributes, which would be a very interesting thing to reflect on, in my opinion. I'd be very interested for someone to write a paper and propose this. Attributes aren't currently used for user-specific code. This would kind of extend their meaning so that users can have an attribute mean something for their particular library. But it'd be very neat. And I think that other languages use attributes for reflection in this way. All right. So a more complex example. We've got our struct with our int I. All right. What we want to do is we want to get information about that first data member. So the first thing that we do is we reflect on S, and we know that we can get the data members of S. So we call get public data members. And that's going to be an object sequence. Once we have an object sequence, we know how to get the first element out of it. Here you can extract the first one. And then we have a meta object referring to the first data member. We can get the name of that first data member. So in this case, member name is going to be equal to the string I. Data members also have types. So I can say, give me the type. Okay, now I have a meta object referring to the type of that data member. And then I can say, give me the name of that type. And that would be int. Okay, see how we're just kind of like pulling this information out of here? It's pretty straightforward. We're just calling functions in a nested way. Now, all of this is happening because these unnamed types satisfy certain concepts. When I call reflexpr of S, I get something which satisfies class, because S is a class. And anything which satisfies class also satisfies record. So there's like this inheritance, this idea of inheritance with our concepts here. And if it's a record, I know that I can get the public data members. I know that that function is valid for things which satisfy that concept. Now, get element T, that works on sequences. So get public data members T returns an object sequence. So I can get element works on it just fine. Now, the first data member is a record member. Okay, and all record members are scope members, and all scope members are named, which means that I can use getName on the thing. All right, I have access to all the functions that are available for record member and scope member and named for that type. First data member is also a variable. It also satisfies the variable concept. And all variables satisfy the typed concept. And if you have a typed concept, you can call getTypeT to get the meta type for that type. And then all types also satisfy the named concept, which means I can call getNameV. It should sound kind of familiar in terms of how object-oriented programming works. So these are the core concepts. Now, I'm trying to see if there's anything up here that I want to call out. But basically, these are the core concepts. They have an inheritance relationship or something like an inheritance relationship. And you can use these as a way to figure out, when you reflect on something, what tools do I have available. Okay, so record is an important one. Classes are a record, structs are a record, unions are a record, and you have this ability to get the data members out of the record. And there are three accessor functions. There are three kinds of accessor functions. The first one is get data members, or get member types. This is unsafe in the sense that it doesn't care about whether they're private or they're public or whatever. This is an easy way to break private and public stuff. So if you want to make a coding standard or something along those lines, or make a tool which checks for bad things being done, you can check for get data members or get member types. If you need to use these things, you might be breaking encapsulation in some way. We also have get public data members. What this will do is just give you the public ones. This one's always safe. And then we have get accessible data members and accessible member types. In this context that we're reflecting on it, is this stuff available to me? So if you happen to be reflecting on a struct or something along these lines in a member function, this will return all the private stuff too. If you're doing it outside of a class, then it will be just the public ones that are available to you. I see some questions. Hold your questions to the end, please. Okay. Now, we also have this idea of going from meta to real. Okay, because you're in meta land, ultimately you want to get back to real world. We have only a couple of ways to essentially unreflect or get out of meta and back into real. The first one is get reflected type. If you have any kind of type, anytime a meta type, and you want to get that actual type out of it, then you can use this get reflected type function. And the example here shows that you can get the type of first data member. So remember back a few slides ago, we get the first data member. You can get the type out of it and then call get reflected type on that. And this will essentially produce int I equals 3. Pretty basic. We also have the ability to get pointers to data members. If you reflected on a data member and you want to get the pointer to that data member, you can use get pointer v to get a pointer out of it at compile time. And it turns out with just these two things, these two ways of unreflecting, so to speak, you can do a tremendous amount of things. Now, named is an important concept. When you reflect on something, frequently you want to get its name. There are a couple of names that are available to you. One is just the name. This is like the official name of whatever the thing is that you're reflecting on. This is what old, bad compiler diagnostics looked like, right? It's true, you get the full thing, but it's kind of ugly. Get display name is basically tapping into compiler technology, which gives you a very readable name for an error message. So the first one, this might be something that you want to use that's going to be cross-platform and be supported by everything. This one might be if you want to have some kind of diagnostic message or something like that in your compilation library. You have access to both. So let's talk about applications, because now we have the base machinery. What can we do with this stuff? That's really important. So back to serialization. If you want to output something to JSON, you just call a function called toJSON. No opt-in. Because this toJSON function, what it can do is it can introspect each of these types. It knows what stood string is. It has a special case for that. It doesn't know what C is, but it'll recurse over what C's data members are and produce some kind of JSON code. So if you can just call cout of toJSON of D, and it will produce the JSON code. You can output it. You can initialize the data type with this stuff. Incredibly easy from the application perspective. Let's go back to the serialization example. So we know we have this serialize function here. What does this become? Well, you could use the curiously recurring template pattern, CRTP, CRTP. And what this boost serialization to class will do is it will look at its template argument, inspect it, and generate that, that function which opts into the serialization library. Huh. Yes, you may. Can you get in trouble because bus stop is still incomplete when that serialization happens? So, if you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just call cout of bus stop, and then you can just this is a template that it's generating, I think you're okay. I mean, CRTP, you do this all the time. Right. Exactly. Yes. Okay. So, whew, it works. Another question.
No, the comment. You can solve that by having the function within serialization that you instantiate later, that then know what class complexity is. That's already how I'm not talking member function. I'm saying friend template. It's the same way.
I'm not going to repeat that. A little side discussion there. What about boost operators? How many of you have used boost operators before? Ah, interesting. Only about a third, maybe. So what boost operators provides you is a way to specify one operator, like in this case, less than, and then generate all the other operators for you. So in this example, we're using stood tie, and less than, if you inherit from less than comparable, it's using this curiously recurring template pattern, and it will generate the other operators for you. So you only have to do one of them. So what can we do? Well, this fictional boost operators 2 library, you can just say, give me the comparisons for person. You don't need to specify that one. You just can use them all. That's interesting. So maybe we could call something like that, call it something like strong ordering. Oh, I guess we really don't need the spaceship operator. Oops. Yeah, it's kind of too bad. I think that we could have solved the spaceship operator thing as a library as opposed to adding more syntax to the language. Maybe I'll write a paper for the next standardization meeting to pull it out. But it has a lot of momentum behind it. Okay, let's look at this example. We have a data type here, struct candidate, has first name, last name, has a variant in there, which is either a school or a job. So you'd imagine it's like some kind of candidate list in some kind of program. It's corresponding to their most recent setting. If they're most recently in school, you want to know the name of the school, and you want to know their GPA. If their most recent setting was a job, you want to know the name of the job, and you want to get a list of the references that they have. So what can reflection do for us here? Well, you can automatically create a user interface for that data type. And I've actually done this before. Before we had reflection, I had to annotate some more things with my data types in order to do it. If you need a user interface in a Jiffy, this works fine. Like sometimes it's not ideal and you want to tweak it more. Then if you want to code something up specific, you can do it. But otherwise, all we're doing here is we're taking the struct, and each element of the struct corresponds to a row. We look at the name of the first element of the struct, which was first underscore name, and we just substitute underscores with spaces. We know that the first name is a string, so there's a widget for a string. Pop that in right there. Last name, very similar. For the variant, any kind of variant you can render in the same way. You just create one of these dialogues. You can't really see the borders on the screen. You create this little square here, and then you give radio buttons to choose which element of the variant you want to use, or you want it to be active, which alternative. If you click one of them, down here in this area, it's going to populate whatever the rendering is for that data type of that variant. So here, school is selected, so you get name and GPA. If you select job, then you get the name of the place, the workplace, and then a list, and however you do a widget for that. Pretty cool, huh? Another really interesting thing is Jackie Kay gave a talk at C++ Now a couple of years ago where she used an earlier version of this reflection TS and messed around with it. She had this idea for coming up with a command line parser. This is really interesting. So the first thing that is done is that you have this idea of type-driven development. So I'm saying what I want my data type to be once I parse the command line. So you can see that there's a verbosity parameter here. It's optional. You can see that there's a service ID, which might be some data type defined somewhere else. Maybe we're using streaming operator to parse that in. And then in main, all I do is I call this fictional library, boost args, and say, parse me the command line. I pass it the data type, and based on the data type, it's going to figure out what the parser should look like. Really declarative, huh? So if I call the program with these command line arguments, so dash dash verbosity equals 3, it knows that how to parse this thing over here because it knows that it's an optional int. So it's going to parse an int. If that were a string, it would allow more things. And similarly for service ID, it knows how to read that in and write it out because service ID is either opted into this or it's using streaming operator or something along these lines. Because verbosity is optional, this library can know that this is an optional argument. You don't have to specify it. And then if I give the program without any arguments, it can say something along the lines of service ID is not specified, that wasn't an optional argument. You can do a dash dash help, and it can tell you what the parameters are, what it's kind of expecting from the user for input. And that's not all. So one thing that we tried to incorporate into the reflection TS before it got published as a TS, one of the requirements was this idea of function reflection. So you can reflect on a function, you can reflect on its parameter types. What can you do with something like that, with that kind of facility? So first off, you're getting all these new concepts. And the names of the concepts kind of give you an indication of the kind of stuff you're going to be able to get out of it. So you can see you can reflect on lambda captures, you can reflect on lambdas, you can reflect on constructors, destructors, all this other kind of stuff. You can iterate over the member functions, and we have special member functions, operators, all this other kind of stuff. But why? So let's say you've got some class foo, and the interface looks like this. Has a function called ls, returns a vector, a string. It's got a copy, a touch, kind of like a shell or something along these lines. With the reflection TS, I'm able to reflect on this stuff and say, go gadget, make me a REST service. And all it needs to do is reflect on this, and it knows your REST service, what the operations are going to be, and knows how to parse the various arguments coming into it. And that's it. That's your boilerplate. So how many of you folks in here would like to use something like this? Okay, everybody. But there's more that you can do. Let's take that same example and say, go gadget, make me an interactive console for a value of this class. And that can look something like this. I call a function ls by typing in its name. It returns a vector of strings, and it just outputs them all. I can call the function copy using fancy keyword arguments, or not. Run ls again. So think about the implications of this. You could take any class that you write and just call, make me a console interactive app to screw around with it. And it'll do it. Now, certainly, if you want to do this in a completely generalized way, it's going to be hard. But the key thing is that it's possible. I mean, this could be a big change in the way that we do development if we can make interactive consoles for any class. Comment?
Can I inspect the contract to know what kind of things you are going to use for this one?
Interesting. So the question is, can you inspect the contracts to figure out what you should or shouldn't be doing? We currently do not have any kind of reflection on contracts. That could be a possible extension. If you have things which have undefined behavior, then maybe you got to be careful about this. You just got to know that you're going to get into undefined behavior. If you're using this for just programmer testing interactive, then it's probably fine. If you have exceptions being thrown, if the contracts are broken, then maybe your interactive editor can handle this gracefully in some way. I guess it all depends on how you do your error handling. Good question. Now, one question is, how do we extend this to be able to give more information to your metaprogram than would otherwise be there? Like the idea of, okay, sure, I can type in ls, but how do I get like help on what the heck this thing is supposed to do? So in your design of your reflection library, you can use a naming convention here. It just knows that anything that begins with help text underscore, this string over here, if it corresponds with the name of a function, then it's the help text associated with that function. So you kind of decorate your types with more information so that you can add help text, or if in the GUI generation case, add hints about how it's supposed to be rendered, things along these lines. But ultimately, like, these were just some ideas. I think that the folks in this room are going to come up with some crazy stuff that nobody's ever thought about. I don't know. Tell me what ideas that you have. Like, let's see if we can make it possible. Language bindings. That's a fantastic example. Yeah. So, the status of the TS. The TS will be published shortly. What I mean by that is that the TS has gone through all the stages that it normally has to go through, and right now is purely administrative. We've gone out, the TS went out for national body comments. We've taken in consideration all the national body comments. All the national body comments got applied to the paper, and that's on me, except for one. A ridiculous thing that we have to do is we have to rebase this on C++ 14. Purely administrative stuff. But anyway, the TS is really close now, and it'll be published pretty soon. We do have an official Clang implementation, which is in the works. Matush is working on that. We don't have a timetable for that yet, but we want to get the TS out there in Clang so that people can start making use of it. Now, in terms of future direction, as mentioned in David's talk, the intent is to reface this with a context-per-based syntax. Why? Well, for one, it makes reflection more accessible. The reflection TS as it is now is template metaprogramming based. And template metaprogramming is considered foreign for a lot of C++ developers. There's immutable data types. It's just very strange to do everything in Angly bracket world. So if somebody wants to get into template metaprogramming, they kind of need to learn a whole lot of new concepts. The idea of const-expr-based syntax is that it looks a lot like normal code, even though you're doing metaprogramming. So that'll be an advantage. So it'll open up to more people the ability to do these kinds of reflection things. And the second point is that it can make metaprogramming more efficient. The way that compilers are implemented right now, every time you create a type, that's a very expensive thing. And as you can see with the reflection TS, you create these unnamed types all the time, all over the place. So once this gets out and you start playing with it, you're going to see early on, you're very limited by your compilation speed in terms of what you can do. For some of these simple examples, if you want to make a simple automatically generated GUI, this kind of thing, it'll be fine. But you're going to notice that the compile time cost is going to get extraordinarily high at some point. And context expert-based metaprogramming should improve on that, at least somewhat. So there is a paper. There are a couple of competing papers for this. I'm only going to mention my own one, which is not Dabi's one. But seriously, we're trying to get together and see if we can build a consensus around something. The big dilemma at this point, the controversy, so to speak, is how nice the API is for users. Does the API look and feel and act like normal good software practices and is not involving too much complexity? That's on my side. And then on the competing proposal side, the focus is more on can we make this efficient in compiler with existing compiler technology? So we'll see if we can cross these lines somehow. So that concludes my talk. Thank you. We have plenty of time for questions.
Hey, David. I'm going to lob you a softball to start. So some of the best C++ programmers in the world are in this room. I think pretty much everyone in this room wants to see this happen sooner rather than later. Probably half of the people in this room who are very good programmers have not contributed to committee things before, have not contributed to prototypes before, but would probably invest some amount of their free time if told what to do. Is there any advice you can give to people in this room who would like to get involved in making this happen?
Yeah. So one really easy thing to do is contact the authors of these proposals. Or if you want to see it implemented in Clang faster, let me know, and we can get you hooked up with Matush, and maybe you can help contribute to that. But I do want to address the comment that you made is you'd like to see this sooner rather than later. And I can't agree more. The committee has decided to tie one migration to another migration. And that is tying reflection to context-expert programming facilities. And my personal preference, and it's certainly not the consensus of the committee, would be to take the reflection TS, put this out there, we know how to implement it, and then everybody can have access to reflection facilities for another 3 to 6 years. I think that would be a great benefit to the C++ world. Of course, when we add context-expert layer on top of that, or on the side of it as an alternative interface, now we have to maintain two things in perpetuity, so there are drawbacks to that. But I would like to see this sooner rather than later as well. Question over here.
Can I use these facilities to figure out what the parameter names to functions are?
Oh, I'm so glad you asked that question. The answer is yes. And then, I'll repeat the question. Can you use this facility to see the parameter names of a function? The answer is yes. Now the next question, which is coming, is well, how can you do that? There are a lot of different declarations, and they can have different parameter names. So the way that we dealt with this is if all of your function declarations use the same parameter names, you're good to go. If they use different parameter names, it'll use one of them, right? Implementation defined. And that turned out to be a good compromise between what compiler vendors can provide us and what we need in terms of usability. Using consistent parameter names would be a requirement if you want to use that kind of facility.
So that's sort of close to my follow-up question, which is I put out a request for having labels on parameters. And one of the objections was that this means that we need to standardize what the names of parameters to every STL and C standard library function are. Otherwise, potentially we have code that will compile with one library but not another, even though both of the libraries are fully conformant.
Yeah, so the comment is that maybe we need to specify in the standard what the parameter names are for every function. Haven't really thought about that. Maybe that's true. I'll take a question over here.
So the get accessible members, where everyone raised their hands, I'll ask that question now. So the reflexper of some widget class, if I call reflexper of widget in one place or reflexper of widget in another place, it gives me different answers based on the enclosing scope, whether it's a friend or not. So I can use this then, so yes, okay.
Yes.
And I can use this then to find out if I'm a friend of a class. And what else can I find out about my current scope?
I don't know off the top of my head all the different things that you can do based on the current scope, but you can reflect on your scope, on scoped things and answer certain queries. So in terms of friends, I don't know if we have a way to expose a way to iterate over seeing like what friends you have, but I guess you could figure out in this like other way by looking at accessibility.
Because I noticed in the slide of like all of the different kinds of types of concepts, you had a bunch of scope things. That would then be referring to the caller's scope, not introspecting on a particular scope, but implicitly on your scope.
Yeah.
Has there been any discussion around reflecting on overload sets?
Has there been any discussion about reflection on overload sets? Yes, quite a bit of discussion about overload sets. In fact, it took a while for us to get to our current incantation. And we started with, you reflect on a function and you get the overload set. It turned out that was problematic in many different ways because overload sets kind of exist only in our mind. There are these like lookup rules that actually are what's really going on underneath the hood. So what we ultimately ended up with in terms of reflecting on a function is you have to reflect on a function being called. And that way you get a concrete function, not an overload set. And that's what you can do. So we have no way to just say like, give me all things that are named foo.
Okay, so analogous to stud is invocable, where you
Yes.
provide the arg set. Right.
Yep.
So you mentioned breaking encapsulation with like gathering member types, and then later there was get pointer to member. When you said break encapsulation, was it only on the metadata, or can I actually get a pointer to a private member?
You can get a pointer to a private member that way.
Ooh. Okay, so second question. I may have missed this, but can you iterate over the requirements of a concept when thinking of a concrete type?
You cannot reflect on concepts at this point at all.
Thanks.
Hi. You mentioned you're only adding stuff, not replacing some things that already exist. But I think you can, in this case, get the names of classes, which was already possible, only with RTTI turned on. I just want to make sure all of this just works at compile time. So now you can do basically the same thing with RTTI turned off, right?
Yeah, that's a really good point that you're bringing up. So the question is related to, like I guess there's currently a hack, I wasn't aware of it, that you can figure out the name of a class at runtime using RTTI information, maybe on some platforms. But the key thing is that all of this stuff is at compile time, right? There was a decision before I got involved in reflection that what we wanted in C++, because it is C++, is to have compile time reflection as opposed to runtime reflection. So that, we can do a lot more optimizations that way, we can inline things, all this other kind of stuff.
Question is, are you going to utilize C++20 ability to pass a string as template argument to look up a class member by string?
Can you repeat that?
I mean, are you going to provide an ability to look up class member by string using C++20 ability to pass string to template argument?
Okay, so the question is, can you look up a class member by string
Yeah.
or something along those lines? Okay. Now, we have everything with compile time reflection. So we're not providing any library facility for you to do that. However, I'm actually not sure what that would mean at runtime because maybe if you could write some function which takes in a string and returns an any or something like that, and it's a template function based on a type, and maybe you can return the data member with that name as an any or something along these lines. I think that what I think that what you're asking is possible. I haven't really thought through about how it would be implemented.
But I meant compile time lookup, not runtime.
So at compile time, looking up passing in a string and then getting the data member, I think that should be possible.
With linear search, definitely. Thanks for the talk. It was awesome. Loved it. But I did see one thing that I've never seen in C++ before, other than all of the other ones that are, and I guess this will cease to be a problem or issue with the const expr rebase. But the get me accessible members, saying that that's a struct is lying, right? Because it's context dependent and the only template parameter it has is the class. But it has a hidden parameter called the context, right? Because otherwise you name mangle that into the same thing every time.
So get.
Well, no. Wait, the reflexper has a context in it?
Yes, it's where you reflexper.
Oh, that's a fun one. All right, thank you.
My question is, can you reflect on
At the point when you're doing a reflexper, that is telling you, that is providing you with whether or not the certain things are accessible at that point. It's not at the point when you call get accessible members. It's at the point when you call reflexper. That's the point.
my question is, can you reflect on the class hierarchy, like get your immediate parent or all of the classes that you subclass on? And if so, how does the curiously recurring template thing interact with that?
So can you reflect on your class hierarchy? You definitely can. So if you have a class, you can say get bases, and then each base is either public or private, and then you can get the access to that type. How does that interact with the curiously recurring template pattern? I don't know. I haven't tried it.
Hi, both great talk. Comment and a question. The comment is, don't reflect over standard library types. This scares both implementers and library groups, and you're not going to get permission, and we will break you with reckless abandon. Now the question is, what about bit fields? I mean, what's the status of it? Because that's been the bane of things like serialization. You can't get pointers to bits in a bit field.
So we're currently not doing anything special for bit fields. There's been another proposal which has come out to try to add bit field support. It just hadn't gotten it through the process in time for the reflection TS, but there is an intent to add some reflection of bit fields for those who like that kind of thing.
So you said reflecting on concept is not possible today. Is there plans to make that possible?
I am not aware of any plans thus far for reflecting on concepts.
Would you sign up for that? If
I would need to be convinced by some use cases.
Okay, thank you.
Hey, so I have a bit of a question. So I saw some of the concepts up there for like callables and things like that, but when you answered, or when you spoke about overload, you said that you can only reflect on the call of a function, so you get one concrete like function, right?
Mm-hmm.
As a person who writes a binding library to a language, I kind of want to be able to reflect over all the member functions, and those might have like overloads and such. So how would I grab like those like member functions and other things that people might want to bind? Because I mean, I don't think I only saw examples of like data members, not necessarily member functions.
Great question. So when I was talking about reflecting on a function, with the function arguments all in there, that's for like using overload resolution in order to figure out what function it is. If you have a member, if you have a class and you want to iterate over all the member functions, even though they're overloaded, that's okay. You can do that.
Okay. Yeah, that's great. Okay.
So according to the examples with generating a command line utility or maybe a web service, I think the reflection is reflection needs a additional annotation just because in that case you need some documentation. And if you cannot place this documentation near the entities which you reflect, it is not so convenient. I mean, you will need to repeat this information somewhere else just to produce some annotation.
Yeah, so there is definitely a drawback of like the approach that I mentioned, where you just put like the documentation right next to it and use some kind of naming convention, because now we see that we have some repeating of ourselves, right? So I think that the idea of being able to reflect in annotations is really a promising one. So I hope that once we reflect on annotations, you can have your own custom annotations that make sense for your particular reflection library, and then we will remove this extra bit of repeat yourself that we still have. Good point.
Okay, thank you.
Your example for when I got the type of a member showed that I got the string int. Does this mean I'm going to get demangled names for all of my type names?
So this is very much a question of wording in the standard. The wording in the standard is its implementation defined, both of those things. But there's a certain intent that we have, and we expect the compiler vendors are going to follow that intent. So in terms of whether it's mangled or unmangled, the expectation is that it's not mangled, that it's in the form that you would expect. You'd want it to be like the same name that you give it in a program.
So this excites me a lot, but also scares me, because now, in the context, for example, of a large company that we might be aware of, any innocent-looking refactoring could mean that you're breaking existing code that's relying on names of parameters, names of structs, and things like that. So I wonder, from a teaching perspective, from a risk analysis perspective, how do you feel about this? How would you encourage people to use reflection as much as possible? Would you leave it just to the experts? How would you ensure that any refactoring doesn't break something that's somewhere else and is reflecting on this thing?
Yeah, I'm really glad you brought that up. That's a really good point. If you give reflection to the masses, they're going to use it as a foot gun. You know, there's a boom every single time. And in fact, the vast majority of uses of reflection-like facilities that I've seen thus far, in particular, people write code generators all the time, and the code generators frequently have reflection facilities. These are like very dangerous. So one of the things that I kind of like about the reflection TS is that you kind of got to know metaprogramming first. So there you just get rid of whole swaths of people. But in terms of like large-scale development, I think that just like anything else, like we need to make sure that if somebody's using reflection, we know like good practice, like, hey, if you're using reflection, you're probably doing something wrong. Just like if you're using plain pointers, you're probably doing something wrong. So we'll see how it works out. But I'm scared as well, you know, of the foot guns that'll happen because people do crazy things. Yeah.
Thanks.
Arthur was first.
All right, well, you've been asked, so this TS is currently based on 11 and you're upgrading it to 14, is that right?
No, the TS is currently based on 17.
And you're rebasing it backward?
Oh, no, it's currently based on working draft of C++ 20. And we're going back to 14.
Going backward, all right.
Yeah. And, and the reason for this is because we're using concepts. And concepts have only been published as a TS. They haven't been published as part of a official C++ standard. And the TS is based on 14. So in order for us to meet all the ISO rules and only depend on published things like standards and TSs, we have to rebase it back. So what's going to end up happening is in the next round of papers, we're going to be publishing 2 papers. One is the paper which is based on the working draft, which is the one everybody's going to use. And then the one which is rebased based on 14, which is going to make it so that we can have an official TS.
Okay, so you've been asked if you can reflect on concepts, and you said no, and whether you can reflect on contracts, and you said no. So I will complete it by asking, can you reflect on modules?
Let me take a guess as to what the answer to that is.
Is it also no?
No, not at this point. Yeah.
So you brought up an interesting point when you said you can iterate over the members of a class. But I have some really abusive programmers who write software at places I've been involved in. And they're going to look at that and say, I can't iterate over members of a namespace. But if I squint, a class looks like a namespace. Is that a gap?
Well, the difference between a class and a namespace is that a class is closed and a namespace is open. But yes, crazy people do crazy things and they will continue to do crazy things. And these are like some more options for them. But but we're gonna just have to kind of like build best practices around this kind of thing and make sure we watch out for it.
Okay.
So you mentioned when I want to reflect on a function, I have to specify the call to the function.
Yes.
Because if it's an overlay, it's that. So, but when I want to inspect the thing the function returns, I would write the same expression in there. So somehow it's a paradigm shift. So at the one hand, with S, we reflect on the thing you put in. And with a function, we don't reflect on the thing we put in, but on the thing it will call.
So when you reflect on functions, you reflect on a function actually being called, but you're not reflecting on the results of that thing. And the way that we model this in our minds is that what we put in there, we're reflecting on that expression, right? Not the results of the evaluation of that expression. So when you currently reflect on a function, the top level thing that you're reflecting, the top level concept that the meta type satisfies is expression. And this happens to be a function call expression. And then you can get the function from the function call expression and then do all kinds of stuff from there.
Okay, thanks.
Hi, good talk. Thanks. My question is, did you consider, instead of using context-dependent accessor for the data members, provide just one accessor, but with returning both like information about the member and about accessibility, like the property was public, private?
So that's a good question. And when you do iterate through all the members, you can query to see whether it's public or private or something along those lines. The reason that we provided the 3 as opposed to just the 1 is first, the accessibility is like a good thing to know about anyway. But second is we wanted to make sure that when we release this, we have an easy way for people writing static analysis tools looking for code quality things to be able to immediately see like, hey, if you're using that, get members one that is unsafe, then there's probably a problem here. Whereas if it's a more complicated, you have to check every single time, then it'd be harder to catch that with a static analyzer. That's why we did it that way.
Could you describe a little bit more about reflection of enums? Can you get the values of each of the enum values or the names of everyone, or is it just the type of the enum?
Yeah, so reflection on enums, you can iterate through all the different enumerators. You can get all their values. You can get all their names. You can do all the things. Yeah. So probably that aching thing that you really wish you could do with the enumerators, you can do it now.
Yeah. And the same for static const express members as well, I assume?
I'm not sure about that one.
Okay.
Yeah.
You said you could reflect on a call expression. Can you reflect on a binary operator? Like overloaded function?
I believe, I know that there was a lot of discussion about that and going back and forth because binary operators are not, they're not really operators in terms of like the way the standard ease is. So you can definitely do, if it's truly an operator, like operator plus or something like that, you will be able to reflect on it. But if it's like, 3 plus 2, I'm not certain if we allow that at all. I don't think we consider that a function call.
Also, just to follow up to that, like for a call expression, can you reflect on the arguments, or is it just the parameters of the declaration?
At this point, I don't think that we have the ability to take a function call expression and get meta information about the arguments that are passed to it.
All right, thank you.
All right. Is it possible to reflect on template arguments to template functions? And if so, on enable if conditions with SVNI?
So you can reflect on template arguments, for sure. I'm not sure what you mean with your question about enable if.
I guess to know under what conditions a function could be called.
To know under what conditions a function could be called.
What?
So that probably not. You can more ask it if it can be called in a certain way, but you can't ask it what are all the ways or characterize that somehow.
Or I guess can you get information about default template parameter arguments or default values for template parameters?
Currently, we do not have a way to reflect on what the default value for template parameters are.
Okay, thanks.
Right.
So what happens if you call reflexper on the result of reflexper? To what problems it can lead?
That's interesting. So I don't even know if we have standard E's that covers this situation. If we do have standard E's which covers the situation, it would say it's not allowed. So I would say, don't do that. Interesting question. It is a class that does have members, but I think we do have standard E's which says, like, just don't do that. But I don't know. I have to check.
So all this talk about the reflexper of an expression has made me realize I don't understand what that means like at all. Like if I say reflexper of f of 42, then you're saying that does overload resolution and says, okay, you're like this expression is a function call and it calls that f, and I'm going to tell you the properties of that f. And if I say reflexper of I, where I is a local variable, I can reflect on the properties of that variable and so on, right? So there are certain expressions that I can reflexper and certain expressions that I'm not allowed to reflexper, like reflexper of 42 by itself would be invalid?
Yes. So you can only reflexper on certain syntax. And 42 is not something which is currently supported.
But even within that syntax, for example, reflexper of a plus b will work if plus is found by overload resolution and not if it's a built-in plus.
Yes.
So there are, I can write an expression or a form of code in a reflexper that sometimes is valid and sometimes isn't. And of course, I can have it dependent on template parameters. So my question is, can I spine on this?
Can you spine on stuff that reflexper works with versus not works with? I have no idea.
Speaking of crazy things, you mentioned that creating a new name is not supported. Has there been any discussion of allowing the creation of more anonymous types and starting to use those anonymous types in more interesting places? Speaking of crazy ideas like prototype-based O and that kind of insanity.
So yeah, we definitely have thought about that, like generating names and all the implications that that would have. One of the things that we really wanted to do with the reflection TS is do an incremental rollout of this thing. And this is the first chunk of features that you get. And ultimately, in the end, we also want to be able to unreflect a whole bunch of syntax. And not only generate new names, but just like define a class at compile time and then unreflect it and actually create it at compile time. So this is the first iteration of this work, and there will be ongoing stuff to add more and more kind of functionality.
So I realized I didn't quite understand the answer to the reflexper question. And the thing that I didn't quite understand was, like, I totally get you can't reflect on the reflexper expression. That's just weird. But on the result of the reflexper expression, do you get a record reflection?
So, like as I mentioned before, I'm pretty sure that we added standard use, which says it is ill-formed, no diagnostic required if you call reflexbur on a meta type or a meta object. So you might get something.
Could we get a type trait? Like, is this a meta object? Because otherwise,
we do have a type trait which says
good.
it is a meta object.
Wonderful.
Yeah.
Thank you.
Okay, what about enumeration reflection?
I'm sorry?
What about enum reflection? Enumeration.
What about enumeration?
Reflection. Reflection about what? I mean, can I get all the elements of enum? Can I?
Okay. Yeah. So I
elements of
answered this
enum?
question a few minutes ago, but yes, you can get, if you reflect on an enumeration, you can get all the enumerators, you can get their values, you can get their names, all that stuff.
Why did you decide to not give an ability to reflect attributes? I think it will be very powerful for tools like ORMs of serialization. Based on my experience on Java and C#, many of these tools rely on attributes or annotations or features, something like that.
So let me ask you a question. Would you be willing to write a paper to add support for attributes?
I'm not sure that I have time for it.
Well, for the same reason, that's why we don't have a paper for.
I suppose without this feature, this proposal may become useless.
What's that? Without this feature, the proposal is useless?
Yeah.
I would tend to disagree, but.
Is the argument of reflexbur an unevaluated context that you can use to force evaluation of context per stuff?
That's not something I've really thought about. I'm not sure what the answer to that is. Okay, I'm hearing people say the answer is yes.
Just one more question. Just one more question to enum. If an enum value is defined by the addition of some other enum values, can I reflect on that, or will I only get the integer value?
If you reflect on an enum, you're not going to get like the actual syntax of how you like constructed it. You're just going to get the value at the end of the day. All right, cool. I think we're done. Thanks, everyone.